Test, 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 1, 2, 3, test, 1, 2, 3, test, 1, 2, 3. Let's see how my drawing works here. Get out of the way. Draw. Oh, this is smooth. How can I quickly... Let's erase this. I see. Can we do... All right, everyone, we are back, and we are going to do our practice problem for fitting and correlation in R. Actually, let me get my pen out of here quickly. Come on, move the time, get it out of my way. Let's go ahead and let's get our pen. So this is going to be for exam 3. So we're going to use the data set chick weight and answer the following questions by plotting weight of the chick 5 on diet 1 on the y-axis and time on the x-axis. So in order to plot this, it'll be helpful first if we let's go to our Canvas site and let's find let's go to get into our Canvas sites. And let's look at let's go to here. Let's go to our pages. And I believe we should be pages week 11, week 12. So we get this. We can open this up. Actually, we can open it up in R. We're just going to open this up. There we go. R is starting to respond here. Great. Yes, you can do whatever you want. So let's go ahead and we are going to upload, or actually not upload, we're going to open. All right, so we are back and we have our functions built in. So let's look at chick weight. Go to our downloads. So let's look at our function here. We're going to control enter. And we are going to look at, and actually we may have to we have here. Different parameters here. So we have weight, time, chicken, diet, and we are asked, what were we asked to do? And as it does this, we're actually, it's going to take look through, and we can start to set up our chick weight. So we're going to be, instead of looking at these empty bars, we're going to be looking at, we're asked to look at, we're going to plot the weight of chick 5 on diet 1 on the y-axis and time, and then we're going to pipe it. So and then let's go ahead. We're going to do chick weight. We're going to filter based on function. What do we want? So we're just going to go like this, and we'll find that once we start to. We're going to pipe the function. We're going to filter. So we'll download this, and I won't based on force you to watch this. We want to find. So see you in just a second. Where chick, all the rows, where chick set equal to 5. Let's see here. Control enter. Could not find function. Oh, I think we need. One last one, our statics. And then hopefully it'll show us, actually, let's just go ahead and do install .packages, statics, control enter, that, and then we're going to control enter here once that's up and running. Doing all these good things, finding that content, loading our packages. I know we said that we would try to avoid this, but again, I think it's helpful at times to kind of, again, make sure if your functions aren't working, it could be that you don't have those packages, especially if it says the could not find function. So let's go ahead. This will be much shorter than tidyverse. which is a very comprehensive package to say the least. All right. Let's go ahead. We're almost there. And we can keep going as we work on this. So again, as this is running, we can actually start to look more at the problem. So we're going to do, basically, we're going to plot it. We're going to look at a linear fit, and then we're going to specify a 98% confidence interval band. We're going to see if it shows positive or negative correlation. So we're just looking for what's our R value for linearly. So we're going to perform the linear fit, identify intercepts R squared values, and then a nonlinear power law fit. So basically, we're going to fit Y equals mx to the a. So just some power law that we can kind of specify here. So we're almost here now. There we go. So now we could do our statics, and then hopefully now ggplot. Let's go ahead. Let's see if we can look at this now. So we see we have this. So we have Chick5 on diet 1. So we want weight versus time. So what we can do now is we can, let's do one more filter. Or actually, we'll do this. We'll pipe it, and then we'll do df select, and we're gonna say df select vars equals, we're going to say we want weight and time. Let's see if that works. Let's see here. Let's see if we can do this. If not, we can deal with this one at a time. There we go. Perfect. So we have our functions here. So now we could actually go and then do one more. So now let's pipe this data in. And actually, we can say, so pipe in this data, and we're going to say ggplot. And we want to say, we have our data already, AES. X is going to be equal to, we need time. Y is going to be equal to weight. And then we're going to do, as we see over here, plus geom point, and then plus geom smooth. We're going to do method linear fit. We're going to do confidence level equals 0.98. And then we're going to plot this. And we have our 98% confidence interval. So we got this. Now we can ask about those correlation values. So we can look at, actually, we can just pull some of these values from here. So we can look at this here. So let's look at the correlation between. So let's do a model fit. We're going to do our Y, which is going to be weight versus time. We're going to do our data is going to be, actually, let's specify our data. So we're going to say this is our, I'm just going to do a little cheat. CW dat. I'm just going to specify it as a variable, and we're going to just set that here. So we can use that for CW dat. Control Enter. And if we look at that, we can look at the summary. So we can see basically our fits. So intercept, we can see here. We can see our slope value here. We can see our R squared, adjusted R squared. Looks pretty good, makes sense. Fantastic. You can look at the coefficients as well. And then finally, we can look at our data set, which is CW dat. We can just pull out the weight and then CW dat. How does that look in terms of time? And you can see it's positive correlation. Fantastic. So we have, what else have we answered? So it is positively correlated. We proved that. We did the linear fit. We found our R squared values. Now we need to find our power law fit. So let's go ahead. We'll set up our power law here as such. So actually, now it's not asking us necessarily to plot it, but we may as well do that just in case. So we're going to adjust, and then, so our data is going to be CW dat. We're going to do, this is going to be our X is going to be time. This will be weight. Nonlinear fit, we're going to do A and then X to the B. We give it some method. I'm going to say B, let's start B at 1. Let's start A at 10, and let's see where it goes from there. So let's do the nonlinear fit. Okay, it doesn't like this method per se. Let's see. Actually, I think it's because we have the SH. I think we need to do SE is equal to F, yeah. So we don't want the standard error because we can't do the standard error because we cannot do that. There you go. So that's our nonlinear model fit. And then now let's look at the values that actually it spit out. We're looking at starting at 10 and 1 maybe. We can do, again, nonlinear fit. We're going to do our CW. Actually, we're going to be looking at basically our weight. Our time is going to be here, except we're looking at it A times B directly, and our data is going to be CW weight, CW dat. Our summary, and we can see the value. So B is not exactly, linear, which is good because in our nonlinear fit, we see our parameters here, and we can look at those coefficients as well. So there you go. That is an example of how you can solve problems with fitting. So you may be asking, where's our R squared? Well, again, that's a linear regression. We're not going to do that in R for our nonlinear model fit. So you don't need to answer that question at this point in this course for getting that R squared for nonlinear fits. So fantastic. Thanks, and we'll see you in the next video. Bye.